Hello, we are from Group 7. We want to explain about Hungarian assignment method in a problem. So we are given the problem statement, the following cost matrix. Each row represents a worker and each column represents a job. The goal is to assign one job to each worker such that the total cost is minimized. So as you can see the value of the cost matrix in the table. First we go to introduction. So in this video, we will demonstrate how to solve an assignment problem using the Hungarian method. The goal is to assign each worker to a job such that the total cost is minimized. So for the step one, we use row reduction. Firstly, we subtract the minimum value of each row from every element in that row. So we need to take the minimum value in each row, and then we use that value and subtract with the current value. So we can get the new value as you can see in the table. Alright, now we go to step 2, which is column reduction. Now we subtract the minimum value for each column. So column A, the minimum value is 3. So you can get the value of the new value in the column. So just now we use row, but now we use column. So the first step is row reduction, and the second step is column reduction.
Good evening, Dr. Faiza. So my name is Karthik Varman, Suramurthy, matrix number 205806. So I'll be presenting regarding the Simon method. And for the Simon method, I'll start off with the step 3, which is the cover all zeros. So the minimum number of lines were drawn to cover all zeros in the matrix. So 4 lines can be used equals to the number of rows, which means we can proceed to assignments. So for this cover all the zeros, we have to use the minimal horizontal or vertical line to cover the zeros which is present in the matrix. And so how we do it is, first we prioritize the column or the row which has the more zero. So as you can see, I have listed down here the column and the row which has the most zeros. So as you can see, the column that has been chosen is column C, which has two zeros, column A, which also has two zeros, column D, which has two zeros, and row W1, which has a single zero in column B. So that's 4 lines, and all zeros are covered now. So when your number of line equals to the number of line covered equals the number of rows covered, it's an optimal structure. So all zeros are covered. Use 4 lines equal to the number of rows. This means the matrix is ready for assignment. Okay, I'll go to the step 4. So in order to make the assignment, we start off with the matrix that we have just now worked with. So how we do is we assign the task with the least zero. So for example, only 1 0 in column B. So assign double worker 1 with job B. So after we already assigned with job B, we cross out the row worker 1 and also the column B. So from the 4 by 4 matrix, it will become to a 3 by 3 matrix. So once it become to a 3 by 3 matrix, we repeat the same process, which is assign task to the least numbers of 0. So row W2 has two zeros, so we cannot assign yet. And row W3 only 1 0 in column C. So assign worker 3 with job C and cross out row 3 and column C. So after crossing out that, we will have a 2 by 2 matrix, which is now much more easier to work with. And as you can see, in the first line itself, we can cross out row 2 and column A. So we can assign this worker 2 with the job A. So after we assign that, we can just basically simplify it and make it into remaining worker 4. We can assign to job D. So after this, we have the final matrix with the workers assigned to their jobs, and we can finally calculate the minimum cost for the assignment, which is 2 plus 6 plus 1 plus 4 equals 13. So for the conclusion, so that is how to solve the assignment method using the Hungarian algorithm. It is a structured method to find the minimum cost assignment for jobs and workers using matrix reduction and zero assignments. So thank you very much, Doctor.